How's it going, everyone? Welcome to the Deep JavaScript course from EX6 as a way to understand the three pillars of the fundamentals of JavaScript, which is a course that is taught by Kyle Simpson, software engineering. That shout out to Kyle Simpson, right? Has previously worked with several companies, and as he went through his career over the years, he made this particular course because he find out things that any JavaScript developer must know. One, and second is to be an effective and efficient JavaScript developers. So in other words, this is a way of how we can now receive formal instructions to understand now this particular language, this tool, when it comes to build now web applications, right? Or to provide interactivity to the language. So because now there is a lot of frameworks out there that help us to bring now interactivity to the browser, which making all of this web app very interactive. So not only in terms of showing a game, so you can actually interact with, for example, if you had a card game with the directions going up, down, left to right. You can also see how is the stock market is doing at real time. You can get the data and show that, right? Or you can do some crew operations or any back office apps where you can see is your analytics, your client, your customers. You can also integrate with CRMs, these customer relationship management systems, or for external service such as the Stripe or Shopify's, perhaps with PayPal, or for any of these cloud providers like the Azure, AWS, or Google Cloud Run. So the idea here is this course is, well, an attempt to formalize this, to provide some structure, especially if you are new to this, or if you are already quite familiar, but you want to already have now particularly structure of how the things should work in a meaningful way, which is in a very storytelling manner, to, well, describe is the JavaScript, the pillars of JavaScript, and what is the intention behind that, and how we can use, for example, is the new ES6 syntax for that. There are also some other things here, for example, with types. This hasn't changed that much in the case of types or the scope or the objects. And this is the reason why these particular questions are asked a lot in JavaScript interviews, because, well, seniors or tech leads want to know if this person knows his stuff, and if it is, great, good, welcome aboard. If it's not, take care, it was a pleasure, bye-bye. There's the door. So this introduction is just as a way to not only understand this particular stuff of how now this stuff works behind the scenes, because most of the time we blame the JavaScript, especially as developers, when things don't go according to our mental models, and then we blame JavaScript for a poorly designed system, where the thing here is that JavaScript has its own particular way of doing things, okay? And it is up to us to say, hey, we need to know how the language works, and by reading is the specification, which is something that a lot of JavaScript developers are barely use that, and they go by. The idea is not to go and buy with this tool. It is to understand how this tool works, the inner mechanism, be able to read the specification in this numeric algorithm way, and therefore now you will have a more solid understanding of what this tool does, and you are now be more effective, which is at the end of the day that's the destination of this. I'm doing all of this is because the end goal of this is to be much more effective with the language, period. So have you ever read any part of the JavaScript specification? That's a good question. We're starting with the evaluator here, and what it's doing behind the scenes, it coheres that string, that value, into a number. All right, and if it's not, okay, and if it couldn't translate that, if you read about this, it's going to convert it into a number. The new value be the result of adding the value plus 1 to the old value, and using the same rule as the operator dot plus. If this is performed, it's gonna put the new value. So in other words, what it's doing is to try to coerce that. So if you see, for example, you're going to try to coerce that into a number. So if we look now, let me do this. If we look now, this as, for example, it's going to define this var x to 5, and if we say this, it's going to now coerce that number first. Okay, so transform the value first into a number, and then add plus 1 and return the original value, and then return the old value. You know what I mean? You say, hey, it's going to return, oh my god, it's going to, my bad. It's going to return is the, but this is on the left side. Exactly. This says, hey, I'm going to return is the old value. I'm going to coerce this into a number if it's possible. If it is, then I'm going to add a new one, add 1, and then return the old value. Right? So it's going to return is the old value in this case. Right? And it's going to return is the old value in this case. So if you want to return is the new value, you can do is something like this. Right? Remember that now the value here is 9. Right? It tells you this 9. But if you want to return now the new value of this addition, this is how you do this. All right? Again, this is how now JavaScript works behind the scenes. If you want to add the current, if you want to return the new value plus 1, this is how you do this. If you want to return is the old value, and after you add the plus 1, this is how you do it. Prefix or or postfix. But again, the idea is that get ourselves familiar with that. So for example, if this is not, let's say you say for some reason, hey, this will be now an A, the letter A, okay? And if we say something like this, it will try to coerce that to a number, but it returns us none, which means that this is not a valid representation of a number. And we have to be careful with that because NaN, they have now different values. right? You want to evaluate this expression. Hey, I want to evaluate this expression. Console.log, right? And say it is false. And this is part of the nuance here that we want to dive deep into the language, which is something that explored yesterday or in the previous videos, right? Where first we went through understand the three main pillars of JavaScript. We have the type, we have the primitive, we're gonna go into the abstract operations, cohesion, equality, TypeScript, which is part of the static, TypeScript and flow. And then we're gonna focus our attention into a scope. When you have the nested scope, hoisting, closures, and models, I am quite familiar with this particular course. It's just to perhaps analyze things for functions and variable declarations or variables, scope variables, block scope variables. And then we have now the objects in plural oriented, right? There is specific type of objects that we can use and how now the inheritance works, right? So, good. Good. Because with that, all right, yeah, because with that, the thing is that we already explored what is the primitive type, at least in the language right now. We look at the ECMAScript for that, script for that. All right, so we can actually let me take a look at the latest standard ECMAScript, the TC39, which is a commit. This TC is using the royalty-free patent policies, all right, to maintain and update the standard. Again, where is it? Publish standards. You got it. Oh, that was okay. A year ago. The last change. Wow. Okay, 15th edition, 2024. Please note that ECMAScript edition 4, the ECMA standard number, ECMAScript standard edition 4 was reserved but not used in ECMA publication process. Therefore, ECMAScript edition 4 as an ECMA international publication does not exist. So the last draft are available here. Reporters should generally only file bugs for this. And this is how you can have access to this. This is the draft. In May 19, 2025. Again, this is a draft. Okay. Can we look at previous versions? As you can see, now they organize is per editions. All right. We are currently now at the edition here, right? I'd like to look at this 14th edition of the language, June 2023. Oh, 2023. That's quite old. Okay. Yeah, all right. So here, when you explore about the notation, ECMAScripts, the overview, web scripting, host, ECMAScript terms and definitions, and the notation conventions, syntactic and lexical grammar, right? In algorithm conventions, and then the ECMAScript data type, language type, right? We have now this. The whole point of this is be able to read about this. You can take a look also to the MDN docs, all right? If you're gonna get yourself familiar with this, this is the reference in JavaScript, right? Not all things in JavaScript appears here, but it can at least give you a sense of how you can actually look at stuff, because here you don't have any examples. One of the useful things, the beautiful thing of the MDN docs is that it has now an examples. So as you can see here, we have this. This is the undefined, the null type, the boolean, the string, the symbol, and the numeric. And this is part of the primitive. All right. And on the number type, we have now the number type and the big int type. Okay. So this is part of the primitive values that cannot be decomposed, atomic values. And then we have now the object types. All right. And how now in objects you have, we also look at the type of operator here. So object type, as you can see, this particular value has these attributes: value, writable, get, set, enumerable, and configurable. You can have an idea of what's going on behind the scenes. All right. Anytime that you create now an object here, it already have these hidden properties. So if we explore a little bit here, let's gonna do this here. And if for some reason we create now an object here to say, hey, it's an object, it'll be an object. So this object have now hidden properties, right? So those hidden property is not showing that correctly. If I do this, I am on the, okay, good. I'm on the object type. So you have now value, writable, set, and get enumerable. Let me open up that here. Much better. So here we say, hey, let's gonna use a var object dot a simple object. You have now an object with all of this property here, right? So if you take a look at this, you have now a hidden property called value, and writable, get, set, enumerable, and configurable. So this is our part of the properties that you can have access to. Type of property for which is present, data property, accessor, and data property accessor or data property accessor, right? So you may wonder, how can I access to this? All right, because at the end of the day, this is just a simple object, and it has something funny here. It has now a prototype, which is a property that points to, before we have something called dunder proto-thunder, that point is to that, right? But again, this prototype is something that we're gonna see that later, but I know what it is, which is a reference to the base object that is accessing to reuse some of the functionality that you might see, that you might need. So instead of repeating yourself all of this functionality anytime that an object is created, so you have now the prototype would say, hey, this is a particular object that lives inside of the JavaScript that has this structure or these functionalities, that anytime that we create an object, we're going to now access through all of these properties, right? So yeah, this is what it is. Okay. Value of to string. Again, here now things change because this is part of the language or host the browser vendors, right? Or host environment. So host environments, or aka browser vendors, in our case, because you can also have, for example, servers in there as another host environment. But in our case, in the browser, they define in this particular way. So far, so good, right? It's not that hard, it's not difficult. We also look at the type of operator to understand what's the value that this object has. And some funny thing, especially with null and undefined, and how now, for example, when you try to get the null from you want to try to get a, for example, let's say you say something like this, right? And then you want to try to get the type of x, right? It tells you that it's undefined, okay? And now here is when particularly concept kicks in. So, for example, you can also have something like this, right? And then say type of G is undefined. You can also say, hey, the value of G will be now null. And if you want to check the type of G, it will tell you that this is an object. Again, for historical reasons, null and null is important to look now at some definition here, some concepts, you know, or kind of emptiness. So far we have now the undefined and the undeclared. So undeclared means that it's never been created, and undefined it means that it was created but there is no value assigned to. However, there is a new concept here, which is called that it is uninitialized, which is part of the TDS sum. This is now from something that we're going to see that later. But these three concepts is part of the essential of a list of concepts when you now reserve space in memory, when you create now a variable here. Okay, so this uninitialized is a concept from ES6, all right, where block scopes or variable like lets and counts, they are never get initialized with undefined. So for example, as you can see here, anytime we use var, see, it is already defined with undefined values. Okay. So for example, you want to take a look at the type of, see, it is undefined. Let as well are in this scope. Let are you say let's of W, right? In this scope, let's now are defined here with undefined. However, when we talk about now function scope, for example, this, so function scope, this function here, and then you inside of that want to say, hey, so if true, and I'm using just true is as a way to get into this particular block, I want to do something like this: console log a variable that is not being initialized or created. So for example, let's say new variable, and then after that I'm going to initialize that, say new variable, right? This is only just for demo purposes. So if you say function scope for that, and you run this, it throws you now a reference error because cannot have access to the new variable before initialization. Here we're slowly but progressively look at another concept, and we're gonna see that later. But the point of this is with type of, there are now a fixed set of values that it will return as a string, okay? And there's a nuance to that, especially when you create something and you assign a null. For example, it returns you an object. And the thing here is, according to Kyle Simpson, is say, hey, if you want to unset a value, you do, for example, a primitive value, you now is set the undefined. But if you want to unset a reference, okay, which is an object, it now gives you an empty object. And this might be the reason of why now we have this kind of stuff. But this is the undefined and the undeclared. It's important to understand that these three concepts, undefined and undeclared and uninitialized, which is that particular error that happened here. Okay, so undefined is when you didn't. Undefined is undefined means that you didn't create. You create that. Exactly. So undefined is that the object was created, so you create that, but there is no value there. Whereas undeclared is that you didn't even create the spacing memory. Okay? And with uninitialized is that, and this is true for block scope variables, so you never get initialize a value with undefined. So if we, for example, do something like this, and we say, hey, I want to know is what is the type of this f, type of new variable. Allegedly it put now undefined, all right, and this might be part of the stuff here in the language, right? So in any case, so we already know this particular concept: undefined, undeclared, and uninitialized. Good. We can move on to special values. One of them is not a number, and it's not a number. It's actually is not a representation, not a valid representation of a number, and these representations are defined by the IEEE 7 association, all right, which is the Institute of Electrical and Electronical Engineering. Okay, so that specification 754 spec actually set the technical standard of how numbers are represented, which is quite interesting. All right. And here is, well, you can now use a number for that, right? So you're trying to now coerce this string representation, in this case an hexadecimal representation for that, into a value which is a valid value 38. So my next age is 39. Okay, and then you can is to try to define not values. Values are non-numeric values. So for example, like nan, it's going to return you an n. But you also need to be careful with that, because nan, this non-representation numeric values are different. So this is not a valid way of how you can compare that with the triple equal. All right. So what you can do is to say, hey, I want to check now. Here we're just checking is nan, this built-in operator. Let's say, hey, yeah, my age here, it is false. It's not a number. Okay, despite that, even though that it coerces that, you know, it says it's not a number. My cat age. It say, hey, this is true because it is a valid representation of a number. Is nan say, hey, my son age, say and say, hey, no, this is true. Again, this is nan methods because it's actually considering is not a number as a valid representation of a number. So that's why it might sounds quite not can be quite problematic. So the TLDR is that let's going to use now a number that is nan for that. You know, my cat age, it's a hey is not a number. It's a true. Even this is not a number. And my son age, it's a so my cat age is this. Remember that at the end of the day, none is a valid number. That's why it returned you now here as true, right? If this is not a number, and the other is that, hey, is not a number, and you pass now a string, it say, of course, now this is false. The thing here is that you have to be careful of what data you're gonna pass to is nan, all right? Because if that is throw you not a number, okay, then not a number is a valid representation of a number, therefore it can quite mess yourself. So not a number is the only value that is not equal to itself. And nan is a number that represents that is not a valid numeric representation. Okay. So far so good, right? So far so good. The TLDR of not a number is that you have to be careful of when you want to use that. Not a number is the only value that is not equal to itself. It means that they are different. How do I know that? Because I read the spec. That's interesting. I did not, but Kyle Simpson did for me. And the other is the negative zero, or the sign here. The TLDR of this is that when you want to use now negatives or positive zeros, or negative zeros like this, the thing is that we use this to indicate is now movement, right? Let's say in a game, card movement, or you want to indicate its direction from left to right, up and down, or for example in trading apps, okay? So you want to say, hey, what is the trend of this? And then you now receive the number if this number is less than 0, and is the number that obvious is, because this is the way of how you can truly verify that a value is what it is, right? You can think of this as quadruple equal, right? Hey, I want to compare now this value that I'm receiving with this negative value of this positive value, right? So then it actually tells you what it is. So trend is true, is not a positive as it is, right? So once we know this, all right, once we know that this valid number is what it is, okay, or if this number is representing is negative values including zeros, all right, then you want to now print that. Let me actually implement this. This might be a silly example here, but quite important, quite interesting, where you say, hey, we want to implement here is this particular function, say format trend. You're gonna receive is a trend as a number, okay, and then you say var direction. It'll be, this is when now the computation happening, or the expression, which the difference between an expression and a statement is that a statement involves an action, and an expression returns a value. So here we say something like this. Hey, if we're for some reason receiving now a value there, whatever value it might be, I want to check if that is a positive or a negative. Depending of that, I want to return something. Now I want to indicate the direction. You say, hey, I want to verify that. I want to evaluate that is a trend. Is a trend, okay, is a trend is less than 0, it's a negative number, okay, is this a negative number, or or that include that, because that's the idea here. If this is a negative number or that number include that, so object.is, which is the trend, and if that number include the -0, right? If it is, because I'm evaluating all the entire expression here, if this is true, then I want you to, well, return me this and say, hey, I don't know how to put that in. That'll be interesting. I don't know how to do that. What about an emoji? An emoji. Down. That's right, down. Or, well, up. Say up. I'm going to use now emojis here. And then I want to return is now the trend. All right. And I want to make the trend to be transforming into a particularity thing. Give me the absolute value for that. And I want to wrap all of this into a template string to compose this string and say, hey, I want to calculate this, I want to compute this, and I also want to I want you to compute what is the direction here, or to interpolate this variable. In other words, this is the value that this variable has. This is part of the interpolation here. So this is the direction, and there you go, right? So if you say format trend, and then you pass now a -3, or if you say now format trend, and you pass now a -0, for example, right? Or if you want to pass now a 1, and then you want to pass now a 2, and there you got it, right? Of course, because it evaluates all of that. So if you say this one, it's gonna give you that. If you pass now 0, it's gonna give you that. If you pass now +0, it gives you that. So, you know, this is a way of how you can actually construct this. Very silly example. Very silly example. Useful for trading apps and all that kind of stuff. And let's get into this now.
To get a better understanding of how primitive values, primitive type values, and some of the special values.
Type check exercise. Type checks exercise. There you go. So to get a better sense of how this value types makes sense, how this value type fit into our program.
Work. We're going to jump into this exercise. In this exercise, we're going to make a polyfill. You're going to define a polyfill for that object.is utility that we just talked about. So in other words, no cheating. You can't go look at the existing implementation of it. You're going to write your own object.is. And in so doing, get some practice with. So in other words, no cheating. You can't go look at the existing implementation of it. You're going to write your own object.is. And in so doing, get some practice with the idea of dealing with these primitive values and their types and the corner cases and things like that. So the instructions here talk about defining an object.is. It's got to take 2 parameters. Remember, it takes 2 values as 2 separate parameters, and then it's supposed to return true only if they're exactly the same thing. Now, normally you would just use a triple equals for that, but the 2 major corner cases on triple equals where it lies are the NaN value and the -0 value. So you're going to essentially need to account for those first, and then if you're not in one of those conditions, then the triple equals would tell you if they are the same value. So the instructions here talk about handling the NaN and the -0, and you can use a built-in utility like number.isNaN, but there's also a way of checking for NaNs that isn't that. See if you can figure that out. You can also figure out negative zeros. So One last little note here is that we're defining a polyfill, and the polyfill pattern, as you can see here, is that you only define something if it's not already defined. So that's what a real polyfill would look like, is that it'd have that if statement wrapped around your definition of your custom function. The challenge here is that you're almost certainly working in a JavaScript environment that already has object.is, because that was ES6, so years back. So if you wrap it in an if statement, none of the code that you write is ever going to run, and you're just going to be testing yourself against the built-in object.is. So as a temporary hack, I would disable that if statement. You can disable it by literally saying something like or true, so that you're always defining one. You wouldn't leave that in, obviously, in your normal polyfill, but for the purposes of this exercise, since you're polyfilling something that already exists, make sure that you disable that if statement in some way, or you can just comment out the if statement, okay? But just keep that in mind. You're going to be working in ex.js. You'll notice that in this file, I have a bunch of console log statements, and each one of them is asserting something about this test. And so the objective is that all of these console log statements all have to print true. That is that each one of these calls all return true, and each one of these calls all return false. So you know you have a passing test when you get all trues and no falses printed out. The way to run this code, you could open up this file and run it directly in Node from the command line. You could copy your code into a console and run it inside of a console, like in your Chrome developer tools. However you like to run your JavaScript, doesn't need any other surrounding information. But you're going to define your object.is polyfill here at the top, and then make sure that it passes all the tests. This will probably take somewhere between 5 and 8 minutes. So we'll break, let you have some chance to work on that exercise, and then we'll come back and talk about the solution. If you get stuck and you need a hint, the solution is provided for you, and it's ex.fixed.js in that same directory. All right, have fun with this exercise. So hopefully you feel pretty good about that exercise. Hopefully it made sense. Let's dive in and try our hand at defining this.
Wait, Jesus. Why? It's because you are quite annoying, bro. You are becoming quite annoying. And then I try to is throw this up. What? Exactly. And then you got it. All right. Good. Good. That's all. That's all. Simple. Simple. All right. So let's go with this X. Exactly. We're about to implement now a polyfill here. We should here add this dot get ignore. Ignore. You got it. Here we are. So the readme say is that this exercise you will define a polyfill for object.is, no cheating and looking it up online. Instructions. Object.is should take 2 parameters. Okay, it should return true if the pass in parameter are exactly the same value, not just triple equal, see below, or false otherwise. For non-number testing, you can use number.isNem, but first see if you can find a way to test without using of any utility. For -0 testing, no built-in utility exists, but here's a hint: -infinite. If the parameters are any of other values, just test them for strict values. You cannot use built-in object.is. That's cheating. Okay. Polyfill pattern. Since you JavaScript environment probably already have object.is, to test your polyfill, you have to first unconditionally define the if gar, and then the if gar, you are done. So for example, like this. So we create now our example here, all right, of our object, this is object dot is, right? So I want to say, hey, if you detect the object dot is, this is what you're going to implement here. This is implementation here. It takes two parameters, right? Let's say parent one, and parent two, right? The difference between parents and arguments are that the arguments is the value that we pass here. Parent is when we define is the function definition, okay? So is the variables that represents the arguments that we pass as function calls in function definition. So we take this. So we want to check all of the type, right? So for numbers, all right, we say this. So we already have now is with type of, right? So if for some reason we say, hey, the parent one, we say the type of parent one, right? It's gonna give us a particular one, right? Say counts type parent one, and of course type parent one, and the other is type parent 2, which is type of parent 2. What type of parent 2, like this, all right? So the next thing is to say, okay, now that I have this, which is going to return now, is going to return a string, okay? We want to make sure if that string is the same, pretty much, and cover some specific use cases, right? And cover some specific use cases. So because we already have our primitive, which is now undefined, you know, we can also have now a map here. Let's say the map of type map, right? Where here you're gonna have is now the undefined, right? You have now the undefined. You also have is the null. You also have now is the is nan, right? We also have now the so boolean. No, exactly boolean, but I'm not sure if boolean is in Maya cases, you know, like boolean here. I think type of boolean. Ah, lovely. Is true. Okay. That. This is in lowercase. Boolean. You also have now has undefined null is then boolean. Exactly is nan, which is not a number. So undefined null boolean here string. There is no symbol in our case, at least in this small test. There are no symbols. So by having this, undefined null none, and if we want to check that is because that's something that is a funny thing. You say this, this tells you that this is a number. Okay, and this is a number. So we already have all of the primitive type, undefined, null, nen, string, boolean, and number, string and number. We also have the begin, and all of this. So what we're gonna do is this. There is actually no need to map this up, to create a map. But if the type parent one is triple equal, or is equal in terms of value of the type parent 2, which means they have the same stream, they return you the same stream because we evaluate that. Therefore, we're going to return now a Boolean value here. Okay, we're going to return now a Boolean value. I want you to evaluate this, and after this evaluation, I want you to return now a Boolean here. You can say Boolean. Right? So it tells me it's true or false. To make sure that we're going to do this. There is no need to do this. And at least this is a very silly example here. If we run this with node, say node of types exercise, and the exercise here .gs. I mean, this is the object.is and the exercise.gs. We actually fixed that. It was quite simple. But it returned true to all of this. But even though with the false one, you know, that's interesting. That's interesting, right? So it returned true to all of that. If we use a triple equal, right? It's still returning true to all of this. You know, and that's fine. That's completely fine.
This object is polyfill. So number one, remember we want an if statement that checks to see that object.is has not been defined. Now I'm going to go ahead and use this little shorthand here, this Boolean coercion. I'm going to say that the negate of object.is. So if object.is has been defined, the only way that it ever gets defined is as a function. So it's definitely on the truthy list, and if I negate it, and if it's not there, it's definitely undefined. So to me, this is one of those places where I'm okay with the Boolean coercion because, hey, we're only checking either undefined versus totally present. There's really nowhere in between. So we're saying if not object.is, and I'm going to throw in this or true for just now, just so we make sure that we're actually running our function. The first time I made this exercise, I made that mistake, and I couldn't figure out why things weren't working, or why things were still working even when I had broken code. So it's easy to make those mistakes. All right, so we're going to define one, object.is equals a function, and I'll just name it.
Exactly. Or true, so you can run this. For false, some of them return false, another true, right? So we need to return is like a map here.
Object.is, if I could ever type. It's going to take two parameters, so I'll call it x and y. You could call it v1 and v2 if you feel better about that. Again, the job of object.is is essentially the triple equals, but also it needs to not lie in the cases of -0 and nen. So we want to pull there's a little bit of nuance here, which I happen to already know about, so I will just jump to it. We want to go ahead and get the an indicator, a true false, if you will, of whether x is a negative 0 and whether y is a negative 0. So I'm going to call it x negative 0.
Exactly, because here we're going to
y negative 0. Those are just going to be variables that I assign to here in a moment. And what I'm going to assign them is the result of testing a value for its negative 0-ness. So I'm going to define a little helper for myself to figure out if something is a negative 0. I wonder if any of you were able to come up with a way of doing that without the built-in object .is. Anyone?
I stumbled across it like a couple weeks ago accidentally.
Okay, so you
cheated.
happen to have already seen it. Okay, cool. Well, how would we do that? This one's a little tricky, so if you didn't get it, don't feel bad. But if you think about a value that is negative 0, what do we know about operations that we can do with 0? So if you say, take a negative 0 and you add a 0 to it, well, if you do that, you know you're just going to get a regular 0. If you take a negative 0 and you subtract a 0 from it, nothing else is going to happen. It's still going to be a negative 0. So adding and subtracting aren't going to help. But what about division? We know that, for example, 1 divided by 0 gives us infinity. What do you think 1 divided by negative 0 would give us? Negative infinity.
Negative.
So there's a way of testing if we have a negative 0. The only way we could get negative infinity is if we had a negative 0. Okay? Maybe not the only way, but that's the way we're going to do it. So I'm going to say if negative 0, take in a value, and I'm going to say, first of all, we need to make sure it's one of the two zeros, because if it was infinity, that would throw our or that would give us a false positive here. So we'll say if v is one of the two zeros, which we can either use the double equals or the triple equals. In this case, they would not have any distinction between the two. So if it's one of the two zeros, and then we're going to say 1 divided by v.
Exactly. If you divide that by v,
has to equal
is equal
negative
to
infinity.
minus infinity.
That's how we could know.
Was that a constant in JavaScript?
Infinity is a built-in.
Oh, really?
Yeah, it's a built-in identifier.
I'll look at that.
So 1 divided by v would give us negative infinity if and only if v was negative 0. Again, the reason for this check is 1 divided by negative infinity would also give negative infinity. So we don't want to have any false positives. Okay, so that's
Exactly. 1 divided by minus infinity is equal to...
how we're going to check if x and y are negative zeros. We're going to call that little utility. So we'll say if negative 0, x, and then we'll say if negative 0, y. Okay? Now, the first thing we want to do is if either side of, if either x or y is a negative 0, then we're going to check if both of them are. But we need to first check if we're dealing with the case that either one of them is a negative 0. Because if either one of them is negative 0, we know that triple equals is going to lie. So we can't allow that to occur. So we're going to say if x negative 0 or y negative 0, that's going to be one of our conditions. And we'll handle what to do with that. Now, if that's not the case, the next thing that we need to check is if both the x and the y are nans. Everybody with me? If both of them are nans, then we want to return true, because we know that's the case where triple equals would return a false false, if you will. It would lie and say false. So we need another utility for checking for nans. You could just use number.isNan, but the README suggested maybe try your hand at coming up with it. Did anyone come up with a way of testing for nan without the built-in utilities? Did you also see that one a couple of weeks ago? Okay. What'd you come up with?
It's kind of janky.
What is it?
But so you, it's an if that checks if param1 is not equal to param1 or param2 is not equal to param2.
Okay.
And then inside there returns type of param1 is number and type of param2 is number. Then they're the only numbers that are not equal to themselves, which means
Okay.
nans.
You're on the right track. I think we can even do this simpler. You're on the right track. The specific trick here is that nan is the only value in existence in JavaScript that's not equal to itself. So if I pass in a nan, it will be not equal to itself, and everything else that would fail. So we can simply say v not equal to itself. And nan is the only one that would return true from that. So I'm going to test if is it nan of x and is it nan of y. And if that's the case, we definitely know return true, because they're both nans, and this is the case where we want to tell the truth. And if neither one of those two is the case, then really all we need to do is defer to the triple equals. So we simply return x triple equal to y.
Because the first, this is the early return. So the first is to say, hey, I want to handle this case, and then this another case, and if it's not, then this one.
Okay, so let's handle this particular case up here. If one or both of them, we're not sure yet, but we know at least one of them is a negative 0, then how do we know if we should return true or not? Well, only if both of them are negative 0. So we can simply say here, return x negative 0 and y negative 0. So the little pre-optimization that I already knew about was that I was going to need to check it twice, so I went ahead and cached it into a variable instead of checking it twice with the function call. Double checking against the solution file as you see over here, and I've written it almost the same. I'm going to just take this code that I just wrote here, and I'm going to, I have a little environment, this program's called run.js, which is like a console that executes stuff. It's not perfect, but it's pretty good. So I'm going to drop this code into here and run it, and we should see all trues, and we do.
Mm-hmm. But initially it give me is all of that. That's quite interesting. Oh, because okay, because it was using is the built-in. It's because it was using as a built-in for that. Okay. All right. Okay. Okay. Cool. 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 Okay. Cool. Is something that happening in Mac OS? Git add everything. Git status. Git commit with a message. There you go. Git ignore, diexercise, ds store, blah 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 blah. There you go. So git commit -m. This is now the first commit. Okay. Perfect. Add everything there. And here's when we're going to now say exactly to true to actually override that behavior. And here we define is the is -0 is -0. Is a -0 or is x -0 or is g -0, right? And here this is quite interesting because that's how you starting to define is this is it -0? Is it -0? And then you pass the x, or is -0 of g. And here we are going to define is what are we going to return what are the use cases that we're going to return. So first we need to say, hey, is so is g negative 0 and g negative 0, right? Or in this case it might be or, because whatever value that we pass here, we need to return is that value here exactly. So we're gonna return now is the whatever value it return this, okay, and the g negative 0. So this is to handle is the cases of negative zeros. The other is to say, hey, else if, to handle now the case of nan number, okay, which is it not a number? Okay, here we're gonna define that, and then if it's not, all right, then we can do this triple comparison, which is the x, we're gonna return is the x and g, right? That's all. And here it defines now two functions. One of them is the negative 0, okay, and the other if it is nan. Exactly.
Why?
If it is
Number.
negative 0 or nan. So here it say, hey, this function called is it negative 0. I'm gonna receive any value, and because I want to make sure that is a negative 0, I want to also say, hey, if this is 0 and 1 divided by x is triple equal to minus infinity, then return this expression. Exactly. So then return this expression here, which is this. Return negative 0. However, when it comes to the is nan, okay, the other is the function is nan. It is nan, not a number. All right. If the function it is not a number, so so what is a number? It is something that doesn't return you the same type of. Is this because nan is the only value that doesn't return nan is the only value that is not the same, because you have a different representation, a numeric representation of that. So we say, hey, if the type of x here, or we can say if the x are different to itself, okay, so for example like this, right? Which is say, hey, if this is different, which is the only value that is different from itself, because that's what we're doing here,
Is that you can simply test.
is the value is the only different is on itself, okay, then you can say, hey, if this is not a number, is exactly, if both of them are not a number, it is not a number, and if it is not a number and it is not a number on G, then return true. Which means both of these values are different values, different type of different values. Then you do is this.
Y. And if that's the case, we definitely return true, because they're both nans, and this is the case where we want to tell the truth. And if neither one of those two is the case, then really all we need to do is defer to the triple equals. So we simply return x triple equal to y. Okay? So let's handle this particular case up here. If one or both of them, we're not sure yet, but we know at least one of them is a negative 0, then how do we know if we should return true or not? Well, only if both of them are negative 0. So we can simply say here, return x negative 0 and y negative 0. So the little pre-optimization that I already knew about was that I was going to need to check it twice, so I went ahead and cached it into a variable instead of checking it twice with the function call. Double checking against the solution file, as you see over here, and I've written it almost the same. I'm going to just take this code that I just wrote here, and I'm going to, I have a little environment, this program's called run.js, which is like a console that executes stuff. It's not perfect, but it's pretty good. So I'm going to drop this code into here and run it, and we should see all trues, and we do. In addition to our primitive.
Okay, that might sound silly, but it is. It's like, so what is not a number, especially here in the specification, is that this is not a numeric value representation, which means that it's not a number, is the only value type that is not that is not the same. Holy fuck. Keynotes here. Key takeaways. Nan is the only type value that is not the same. A minus infinite is a valid minus infinite is useful to determine or to compare positive or negative values. Holy moly. Interesting. And the other is this one.
Primitive values, we also have fundamental objects. And by the way, this is a terminology that I think was somewhat recently introduced in the spec. These used to be referred to as built-in objects or maybe even native functions. I've referred to these historically as native functions. I think they're more commonly now referred to as fundamental objects. So whichever phrase works for you, pick and choose. But if you're reading the spec and you see something like a fundamental object, that's where this comes from. So what are these fundamental objects? Are they types? Sort of, but not really. This is like the kind of bolted-on object-orientedness of JavaScript, the almost Java-like mutation of JavaScript, where we have, in all of those cases where we had primitive values, we now also have object representations with similar behaviors. So like in Java, when you want to make a string and you call new capital S string, we have things like that in JavaScript. I don't think you should use them, but I do think you should understand them. So these are the ones where you really should absolutely use the new keyword. Object, array, function, date, regular expression, error. If you need to construct an object of that fundamental type, then use new object or new array or new function. Probably the key one here that I would use would be new date, for example. Okay? But there are other ones that are fundamental objects which could be used with new, but I'm going to tell you should definitely not use them with new, and that is these three, string, number, and Boolean. They can be used with new to construct objects of this form. You should absolutely never do that. You should use them only as functions, not as constructors. And when we talk about later in coercion, you'll understand the usefulness of them. But string, number, and Boolean, when used as a function, coerce any value to that respective primitive type. So that is a far more useful utility of those than the fact that they can construct this weird Frankensteiny object. So an example here, again, date. I would say new date to construct the date object. Why? Because there is no date literal. If you want to make dates, you've got to do new date. That might be the only reason why I think we should keep the new operator around, is because I need to make dates from time to time, and that's the only way to do it. I do hope that maybe someday they add a date literal, but we don't have that yet. So I can construct dates, but if I have something that is not already a string, for example, if I got a JSON object back that had my GPA from college in it, here I am telling you what my GPA in college was. If I got back a JSON object that was my transcript from college and it had my GPA in it, but I needed to represent it as a string, capital S string function does that and does it well. It converts it to that string representation.
Fundamental.
In addition to our, and by the way, this is a term as native functions. I think they're more commonly now referred to as fundamental objects. So whichever phrase works for you, pick and choose. But if you're reading the spec and you see something like a fundamental object, that's where this comes from. So what are these fundamental objects? Are they types? Sort of, but not really. This is like the kind of bolted-on object-orientedness of JavaScript, the almost Java-like mutation of JavaScript, where we have, in all of those cases where we had primitive values, we now also have object representations with similar behaviors. So like in Java, when you want to make a string and you call new capital S string, we have things like that in JavaScript. I don't think you should use them, but I do think you should understand them. So these are the ones where you really should absolutely use the new keyword. Object, array, function, date, regular expression, error. If you need to construct an object of that fundamental type, then use new object or new array or new function. Probably the key one here that I would use would be new date, for example. Okay? But there are other ones that are fundamental objects which could be used with new, but I'm going to tell you should definitely not use them with new, and that is these three, string, number, and Boolean. They can be used with new to construct objects of this form. You should absolutely never do that. You should use them only as functions, not as constructors. And when we talk about later in coercion, you'll understand the usefulness of them. But string, number, and Boolean, when used as a function, coerce any value to that respective primitive type. So that is a far more useful utility of those than the fact that they can construct this weird Frankensteiny object. So an example here, again, date. I would say new date to construct the date object. Why? Because there is no date literal. If you want to make dates, you've got to do new date. That might be the only reason why I think we should keep the new operator around, is because I need to make dates from time to time, and that's the only way to do it. I do hope that maybe someday they add a date literal, but we don't have that yet. So I can construct dates, but if I have something that is not already a string, for example, if I got a JSON object back that had my GPA from college in it, here I am telling you what my GPA in college was. If I got back a JSON object that was my transcript from college and it had my GPA in it, but I needed to represent it as a string, capital S string function does that and does it well. It converts it to that string representation. So earlier we described, and I mentioned a thing called an abstract operation. If you recall, I showed you the to number, and I said that's an abstract operation. So let's talk about what those are, because they are the fundamental building block that makes up how we deal with type conversion. So you see here in the spec that we have these abstract operations which perform fundamentally the task of type conversion. In JavaScript, we refer to type conversion as coercion. Okay? So when you think of conversion and coercion, you should really think of them as interchangeable, at least as far as JavaScript is concerned. The first abstract operation that we have is called toPrimitive. Now, obviously, if we don't have a primitive, we need to turn it into a primitive. So if we have something non-primitive, like one of the object types, like an object, an array, a function, whatever.
All right, so, well, that'll be all for this video. Take care. Bye-bye.